Welcome to another thrilling edition of Comet Algebra. This video is for Algebra 1, Chapter 6, Section 5, Parallel and Perpendicular Lines. In this section, we're going to be discussing the relationship between slope and parallel and perpendicular lines. And we're also going to learn how to write the equation of a parallel line given a line that it's parallel to just by looking at their differences, and the same thing with perpendicular. So let's start by defining those two terms. Parallel lines are lines that lie in the same plane. In other words, they lie on the same flat surfaces, but they have no points in common. In other words, they run side by side and they never cross and never meet, sort of like the two railroad tracks. One thing you have to know about parallel lines is that they have the exact same slope, but of course they have different y-intercepts. So if you were to look at this picture I have of parallel lines and think of it in terms of the xy axis, if I attempted to draw that in here, you could see that here they cross the y at two different points, but the slope I drew looks like approximately up 1 and over 2, up 1 and over 2. Their slopes are the same. This would be a 1/2 slope, but different y-intercepts. Perpendicular lines are defined to be lines that meet each other at a right angle, and a right angle is defined to be 90 degrees. And the slopes of perpendicular lines have a relationship too. Obviously, they're not the same because they cross each other, but their slopes are negative reciprocals of one another. So for instance, if this slope, and you can see this slope of this line is definitely positive, maybe it's up 1 and over 3. That means the slope of a line that hits it at 90 degrees, negative means you would take the other sign, so this would be from a positive 1/3, this slope would be negative. And a reciprocal means that you flip the fraction. I'll just give you an example here. 2/3, the reciprocal of 2/3 is 3/2. You flip it around. So if we have the negative reciprocal of 1/3, that would be -3, meaning the slope of this line is down 3 and over 1, down 3 and over 1. So please make note of that. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals of one another. In this first example, we are asked to determine whether these two lines are parallel. And just so we know what the strategy is, if they are parallel, they would have the same slopes. And so if we find the slope of both lines and compare them, if they're the same slopes, we would say yes, they're parallel. If they're different, we would say no. So the easiest way I can think of is to find the slope is to change both of these to slope-intercept form. In other words, solve both of them for y. So let's start this first one. Let's subtract a 3x on both sides. So then I'd have -y equals -3x plus 6. And then some people think of it as dividing everything by -1, and some students think of it as multiplying everything by -1. But either way, the sign changes for all three terms. So we have y equals 3x minus 6. So clearly this slope is 3. So let's do the same thing over here. Let's solve for y. Start by adding a 9x to both sides. And I'd get 9x plus 12. And then to solve for y, we need to divide everything by 3. So we get y equals 3x plus 4. This slope is also 3, so we can say yes, the lines are parallel. And because we noticed that their slopes are the same, and we also did notice that they have different y-intercepts. In this next example, we're kind of going back to section 4 where we're asked to write the slope-intercept form of a line. So this is what we're after, a y equals mx plus b. So we need m and we need b. And what are we given? we're given that the line we're supposed to write the slope-intercept form of is parallel to this line and passes through this point. So once again, I need to find M and I need to find B. Well, the only way I could find M is that I know it is the slope of this line is the same as the slope of the line I'm looking for because they're parallel, so I know that their slopes are the same. So if I can swipe the slope from this equation, that will be the slope I'm looking for. I do not want the y-intercept from this equation. I want the slope. So again, probably the easiest way is to solve for y. So let's start by subtracting a 4x from both sides and then dividing everything by 3. So I got y is negative 4/3 x plus 7/3. So this is what I was after. My line is parallel to this line, so their slopes are the same. So now, once again, I need to find b, and this should sound very familiar to you. Out of these 4 letters, I know 3 of the numbers, and I can plug them in. The negative 5 is the x, the 9 is the y. So if I say that 9 equals, the m is negative 4/3 times x, x is negative 5. I'm going to put it over 1 so that I can easily see how to multiply these fractions. And then plus b, which is what I'm after. So let's multiply the fractions first. Negative times negative is positive. So I have 20/3 plus b. I need to subtract that 20/3 from both sides. So I need to write this side with common denominators. 9/1 can be changed into thirds by writing it as 27/3, and I'm subtracting 20/3 from that to get my b, and I end up with 7/3. So now that I have the m and the b, now I can finally write the slope-intercept form of that equation. So y equals negative 4/3 x plus 7/3. Example 3 is just a quick exercise on taking the negative reciprocal of a number. The negative reciprocal of 8/5, since it's positive, it would be negative 5/8. So these two numbers represent slopes of lines that are perpendicular to one another. The negative reciprocal of positive 9 would be negative 1/9, and the negative reciprocal of this would be a positive 7/13. And once again, these are slopes of lines that meet each other at 90 degrees. So let's use that knowledge now. In example 4, once again we're asked to write the slope-intercept form of the line. That means I need to find m, I need to find b. The line I'm looking for is perpendicular to this line and passes through this xy. So if I want the slope that's perpendicular to this one, that means I want the negative reciprocal. This already is in mx plus b form, so that's very nice. This line has a slope of negative 4. Now my line is perpendicular to this line, so I don't want to use the negative 4. I want the negative reciprocal of that, which is 1/4. And then once again I need b. So of these 4 letters, I know 3 of them. So let's plug them in and then find the missing b. So I have 7 equals 1/4 times 2/1 plus b. 2/4, when I multiply that out, is the same as 1/2. So let's subtract the 1/2 from both sides, if I can write that. So in common denominators, I have the 7 is 14/2 minus 1/2, and that gives me 13/2 for the b. And so now that I have both of these things, I can write it in slope-intercept form, 1/4 x plus 13/2. And there I have the equation of the line that's perpendicular to this one and goes through this point. In this last example, we're given 2 lines and we're asked to tell, are these lines parallel to each other or perpendicular or maybe neither? So we know that we have to check the slopes. If the slopes are the same, we'll say that they're parallel. If they are negative reciprocals of one another, we will know they're perpendicular. And if they're not related to each other in any way like that, we'll say it's neither. So I think the easiest way to find slope is to put it in slope-intercept form. So let's subtract a 2x from both sides. So I got 5y equals negative 2x. Divide both sides by 5. And we have y equals negative 2/5 x. So we have the first slope that is negative 2/5. So let's check this slope now. So we'll start by subtracting the 4x from both sides. So I have y equals negative 4x plus 1. So this slope is negative 4. These two slopes are not the same, and they're not negative reciprocals of one another. So we're going to say that these lines are neither one of these things. All right, that's it. Now you have the knowledge you need for section 5. So have fun with math.